Integer exponents. So our first concept is looking at zero and negative exponents, but we want to go over positive exponents just to make sure everybody's on the same page. So with a positive exponent, you're looking at multiplying a number, whatever the base is. In this case, we'll start with 2 to the third. Okay, and you're going to multiply that by 1 a number of times equal to the exponent. Okay, so this is 1 times 1 2, 2 2's, 3 2's. Or 1 times 2 is 2, times 2 is 4, times 2 is 8. Okay, often this 1 gets dropped because anything times 1 is itself, so it doesn't really need to be here for positive exponents. But I like to include it because when we look at 0 as an exponent or negative exponents, it is really helpful to remember that it's there. Okay, so just another one real quickly. We'll look at 3 to the second. Keep it simple. Okay, be 1 times 3 times another 3, since my exponent is 2, or 1 times 3 is 9. Okay, positive exponents, I think we've all pretty much got that. Okay, now for the 0 exponent, this is where that multiplying by 1 helps. Okay, so if we have a, say, 2, we'll keep our base 2 to the 0. Okay, if we start our process just like it was a positive exponent, we'd say, okay, we have 1 times, well, we're not going to multiply it by 2 any times, so we're just left with 1. Okay, and multiplying, or sorry, a exponent of 0 on any base is going to equal 1. Okay, it could be a fractional base, so 2 sixths to the 0 power still equal to 1. Pi to the 0 power still equal to 1. Okay, so it doesn't matter what the base is. If it's taken to a 0 power, if the exponent is 0, your answer is going to be 1. All right, you can, if you look at the table I have here, and this might be a good thing to copy down into your notes, you can see, yeah, if we're using the same base, right, we're at base 10 right here, and every time we go to the left, we increase our power, we're multiplying by 10. That's the same as saying every time we go to the right, we're decreasing our power, we're dividing by 10. Well, 10 to the first is going to be 10. If we divide that by 10, we're going to be left with 1. Okay? A lot of people get confused and think that 10 to the 0 or anything to the 0 is going to equal 0. Right? But that's not the case. Because you have that 1 there, you're just multiplying it by the base 0 times. Okay? But our 1 is still left over. All right. Let's look at negative exponents. So we saw from our table that every time we decrease our power, we are dividing by 10, right? That has the same effect. It's just the opposite of increasing our power and multiplying by an extra, I should say base, right? Because our base doesn't have to be 10. It's just for this table it is. Okay. So when we get to 0, we're down to 1. When we go down again, we're going to end up with a fraction. Okay? Because we basically have 1, and then we're dividing by that base again. So if I have a negative 1 as my exponent, we'll say 3 to the negative 1, okay, that's going to be the same as saying 1 divided by 3. Okay? You're basically dividing by the base that many times. So if I had 3 to the negative second, I would have 1 divided by 3, and then dividing this 1 by 3 again, or multiplying these 3's together, okay, to get 1 over 9. All right. The trick to doing this that can help some people is, say I had like 5 to the third, or sorry, 5 to the negative third, is instead of writing it out like this, you can always just say, okay, my negative becomes my fraction, and I've still got 5 to the third underneath it. Okay, it's going to have the same effect. So now, what is this equal to? Well, it's 1 over 5 times 5 times 5, or 1 over 5 times 5 is 25, times 5 is 125. Okay? When you have a negative base, that can sometimes throw people off. All right? Keep in mind, your negative exponent will not make your answer negative. Okay? If your original base is positive, your answer is always going to be positive. It might be a really small fraction, but it's always going to be positive. Okay? If your base is negative, then you might end up with a negative answer, but only if your exponent is odd, right? Because if I have a negative, we'll go back up to this one, negative 3 to the negative second, that's going to be 1 over negative 3 times negative 3. I've got an even number of negatives, so a negative times a negative is going to be a positive. Okay? If I had an odd number of negatives, then it would be negative. Negative 3, negative 3, negative 3 is going to equal 1 over negative 27. Okay? So keep that in mind. However, one thing to note is if you see a problem like negative 3 to the second or to the negative second, all right, unless you see parentheses including that negative sign, the negative sign is not going to be part of the exponent. Okay? A lot of times in your book or like on a test, it'll do you the favor of doing it like this and giving you parentheses. But on your calculator or when you see it on a test, if you just put in this as a problem, negative 3 squared, it's going to do them separate. Your calculator would give you negative 9 as the answer to this, which would be wrong. So be careful with that one.